Pythonic deployments of Python applications. But before we dive into that, let me first tell you what I came here for last week, really. I came here to heal from the damage I suffered at work. I work in Europe's second richest country, and I suffer every day. I recover in my spare time. So that's what I do. I work and I recover. I work and I recover. I don't live. And whenever I can afford, I spend time in Italy. Yes, in Italy. And to heal from that damage that I suffer from work, to spend time with the warm-hearted people in the sun, to feel the passion that the people have here, and to make friends. So what's wrong with Europe's second richest country? There are things that money can't buy. Friendship, open-mindedness, passion to work on great results together. Willingness to collaborate, pair programming, taking the blame for failure as a team, holding hands in stormy weather. Yeah, maybe it's also the attention that we heard in the keynote this morning. So money can buy an agile mindset, in essence, and that makes me sick. So what did you come here for? So if you're not Italians, that's probably what it is. It's monuments. And if this is your first time in Italy, that's all right. But if you return, you should really come here for the country and for the people, for the passion for everything, for the attention that those people have, per la voglia di far festa. And there's a lot to learn from this country, and there's a lot that Italians do right. And some of the things we just need to understand better. And for example, why Italians try not to pay taxes. Did you know that the value-added tax in Italy is 22%? That is insane. And you know what Italians do about it? They don't pay it whenever they can, because it's unfair. And on the flip side of the coin, do you know why the tax is so high? Because when only a third of the people pays the taxes must be 3 times as high. Logical, right? And there's more that doesn't seem logical at first sight. So take these words on the slide here, for example. So on that side, you see the female gender words. They all end with A, you know, pizza, vita, famiglia, ragazza, bella donna, and in the plural with E. And then on the other side, we have the male gender words. They end all with O and with I in the plural, you know, ragazzo, uomo, libro. But then it starts getting complicated. We have these E, you know, E, wasn't the plural here with the E? Yeah, you have padre, mese, mare, fiore, etc. Okay, fine, this probably comes from Latin. But then it even gets more complicated. You have la mano, the hand, and in plural it's le mani. Oh, okay, so we have the article from the left side, and we have the suffix from the right side, and the same for the plural. Okay, well, at least it's consistent. But then, even worse, we have the deck chair. You know the deck chair? It's an important thing to have in Italy on the beach. And it's la sdraio and le sdraio, the plural. So what's happening here? So this is so complicated that even Italians don't get it right. You know, in some regions of Italy, they say la sdraia e le sdraie, vero? Tipo a Roma. My wife is from Rome. And my wife learned in Tuscany that it's actually la sdraio, le sdraio. Perché? Why? Because there's a reason for it. For real, it's la sedia a sdraio, the chair where I can lay down, and le sedie a sdraio, the chairs where I can lay down. Okay. This was your personal dose of Italian for today. I hope you enjoyed it. My name is Peter Bittner. I'm a developer of people, companies, and code. You'll find me on Mastodon. I've almost left Twitter. And I'm also on GitLab and GitHub, a little bit on Bitbucket still. And I'm an open source developer and a Linux person. I'm a maintainer of and co-maintainer of various open source projects. And I'm your host for learning about Juju and Charmed operators here at PyCon 24. One important disclaimer before we get into things. While I use the logos and the colors of Canonical and Ubuntu, I'm in no way affiliated to Canonical. Okay? I'm in fact, I used to be a fanboy of Ubuntu, just like iPhone and MacBook users are Apple fanboys, but even that preference is not as strong anymore as it used to be. And also, maybe some of my views are actually wrong, as I'm neither a Juju nor an active Charms developer, so take my explanations with a grain of salt. All right, let's step back a bit and look at how applications are deployed, so how you maybe deploy them or have deployed them in the past. So what are our options when we deploy applications? So the simplest thing, the straightforward approach is a scripted setup. So with Python, we would create a virtual environment, we would copy source code to the host. Maybe you use Git, so you initialize, you clone a repo on the host, you pull it when you deploy, and maybe there is some bash involved, or 10 years ago, there was Fabric, I think, in Python, or you do Ansible nowadays, which is not much more than just bash and SSH, or some other configuration management tool, right? If you want to get a little bit more advanced, a little bit more structured, then you create a Python package. That is something that you can pip install your own software. That's a little bit more clean. You can also uninstall it almost cleanly. The dependencies stay there, but it's a clean approach. Yeah. Yeah. Oh, then we have got the system package. System packages, this is when you have more than just your Python source code. You have maybe configuration files that go with your application, and you target a specific operating system. You have a package manager that takes care of deployment, so you get some support that you don't have when you do things on your own. Then we get closer to what we do when we work in cloud-native environments. We run containers. That allows us to copy and install software in a container image. So we prepare things up front. We work with a Docker file. Maybe we work with Docker Compose, either for development or even if we want to orchestrate a simple setup on a VM or something. You have clean isolation. That is an important thing of it. Okay. I should have changed the batteries. Okay, so, and then we have Kubernetes. You maybe use Helm when you use Kubernetes, or customize depending on your preference. You write a lot of YAML code. You use something like kubectl apply in your pipeline if you do the push-based approach, or you use GitOps, which is the pull-based variant, etc. Right. So Kubernetes you use to make things work together, and that's what you describe in the YAML file, right? In YAML files. And then there is more, though, that needs to be done. You need to take care of backups. Maybe you don't think about it first, but sooner or later you figure out it would be good to have backups because you never know if something goes wrong. And then remember, a backup is only worth as much as you can restore it. So if you never try to restore it, don't even back up. you want to know if something goes wrong. You want to know maybe upfront when there is a tendency that something goes wrong, whether your application maybe gets closer to an OOM, out of memory error. You want to do error tracking and tracing. You want your software to be integrated with other software. Probably you have to do this manually. You have to do this in YAML or something. You want to do upgrades, and then the impossible. You want to migrate to new hosting, because everybody goes to Microsoft Azure. Yeah, move there. Okay, we start from scratch. Then you figure out, oh shit, oh, sorry, it has become too expensive. So how we move away? Yeah, that will be a project of probably a year or half a year, minimum. So, okay, so let's look at what the before mentioned approaches actually do. They solve different problems. The scripted setup, with that one, you try to bring up the same setup as locally develop. That's what you do. With the Python package, you install the application the Python way. You can do pip install. It's more structured. It's cleaner to read and deployment configuration. And pip takes care of where the source files are placed, so there are side packages, and it installs launcher scripts. You can even package some data files if you need. With a system package, you combine the binaries and config files, data files, and you follow the conventions of a distribution of your OS. Yeah, and with a container setup, you satisfy it's possible that you free yourself from resolving the dependencies over and over again when you have a new client, a new target environment, because you satisfy those dependencies independently from the target environment, and you're all set when you have a new target environment to face. Great, and with Kubernetes, what you actually do is you declaratively define how containers should work together. You don't make things imperatively. You only say what is the what. So what do I want to have, and the how is being taken care of by the Kubernetes engine. So the Kubernetes engine takes care of how you scale your applications, how you start it up, if something goes wrong, if it goes OOM, if it's restarted, and so on, or if a node goes down, that it's being transferred to another node so that there is no outage, etc. You don't do this yourself. You should only say what you want. Kubernetes takes care of the rest. And that also means self-healing environments. So that's the idea of Kubernetes. You define how the system should react, what is the state you want it to be in at all times, and if something goes wrong, if an interruption happens, Kubernetes takes care of the rest. That also means you should not interfere or correct the state manually. So don't do kubectl something and mess with the cluster, even though everybody does it, right? But you shouldn't. So automatic operations should do the job. That's the actual idea. Great. Battery outage again. So, but then there are more things. There's things like these day 2 operations that are not covered by any of those solutions here. So this is the monitoring, logging, alerting, updates, configuration changes, backup restore. Yeah. So wouldn't it be great if we could have that solved by technology instead of doing it all manually ourselves? That's where Juju comes in and all its related tooling. Okay, so the idea of Juju, that's actually a West African word, so like everything from canonical, Ubuntu is, what is it, humanity to others, and Juju is the magic that deals with good luck, and the charm is a spell, so it's like Juju does some magic, so that's practically the mission or so. So the idea of Juju is that in addition to deploying your app using containers or not, you also cover and have entire control over day 2 operations. Also, your application setup should be self-contained, so you shouldn't have to mess from outside. Your application should be able to, for example, grab the secrets for accessing the database from the database itself, where it's generated. And it should be able to connect to other components. And all that's kind of magic things like auto-provisioning, configuration, secrets, or something like that. Canonical tries to provide a uniform tooling for all those aspects of the concept. And also to solve various related problems. Juju is the orchestration engine, and it manages the application operation on any infrastructure. It uses charms. A charm is a software operator. So a software operator is a piece of software. Here is written in Python code, and it automates all aspects of the application's life. Then the lower 2 parts, rocks and snaps, maybe you've certainly, if you use Ubuntu, you've certainly heard about snaps. They are like a bit hated. But rocks are, it's like Docker, OCI images, standard. They're trying to make Docker images safer. That's what it is. But all those 3 tools, by the way, this you see is written in Go. These are written in Python. These are CLI tools then, Charmcraft, Rockcraft, and Snaps. Sorry. And Canonical tries to provide uniform tooling for that. That's basically it. Good. So currently, with Juju, there's still this distinction between machine charms and Kubernetes charms. And machine charms are basically charms for bare metal and VM and system containers, so you can deploy an application to something else than Kubernetes. And Kubernetes charms, for Kubernetes charms, the target environment is Kubernetes. Maybe I forgot to mention that what is actually interesting about Juju. So what Juju does, what Canonical tries to do with Juju, is they actually try. Let me just go back if that was there. No, that's fine. Probably it's still to come. So what they try to provide is that actually we saw this in the first slide here. So what Canonical's approach is actually interesting. That's an important to note. I forgot it. I'm sorry. So what they try is to provide a total abstraction across all different workload environments. So they've even a general term for a cloud, a VM, bare metal. They talk about a substrate. So you deploy to a substrate, and it can be anything. You're not doing something for Kubernetes, you're not doing something for Azure or so. You're doing something to deploy something wherever you want to go. That's their idea. And maybe maybe you don't know, and I don't know if you've noticed, but in the last 5 to 10 years, Canonical has built an impressive cloud infrastructure tooling portfolio that goes way beyond just Ubuntu, and the discontinued Ubuntu Phone and Ubuntu TV. And interestingly, they have learned a lot from the Ubuntu Phone than over IoT, because when you remove the GUI, then you have all the IoT tooling, and that's where also snaps come from, and then in the end rocks and so. And most importantly, Canonical tries to elegantly simplify operations and infrastructure from IoT to VMs, private and public clouds. They also address one of the main concerns of virtualization and Kubernetes. And what could that be? That you have this infrastructure overhead by too much abstraction. You know, you can do everything in Kubernetes, but then it gets slow and complicated. So with Metal as a service, you can turn your own physical service into a cloud, and you can leverage the speed of bare metal. So this is that logo here. And this is simply done by data center automation. And this is all super elegant, and I think we can attribute this to Mark Shuttleworth. And because if you know Ubuntu a little bit, you've always seen Ubuntu is simpler to install than any other distro, and it has it has a super unprecedented startup speed like no other distro. Yeah. So that's my personal compliment to Mark Shuttleworth. So let's come back here. So you can see there's still a difference between Kubernetes deployments and machine charms here, but you can see there are similarities, and Canonical is actually working on uniforming these things. And so you have the controller here, Juju controller. You have a client here, Juju client. So these are these CLI commands that you can think of that you would send requests to the controller, and then that makes the agents here do their work, basically. Pebble is a replacement in the cloud world for systemd, and so they try to uniform everything. Good. So let's go through those parts. There's some new vocabulary to learn. Thank you. But once you actually buy into the idea of generalization, you fall in love quickly with those names. You've got, don't read this to you. You've got the documentation here. It's all well documented by Daniele Brocida, by the way. So he's the wizard behind all the well-structured documentation. Charms are these Python logic that drives the operators. You've got this CLI tool, Charmcraft, that does init, pack, login, upload. And you can see from these comments here that there's something more behind it than just preparing a software solution. And the main objective of Canonical is actually, and that's what those comments are hinting at, to build an open source library of curated charms. You know, so you have all those charms that you can install. And remember that Canonical is, in the end, an infrastructure company. So what do we do there as application developers? But nothing is stopping us to use Juju also for, and Charms also for custom applications. And actually, there is some work in progress at Canonical for that, for Flask, Django, and so on. Great. Rocks. Oh, great, thank you. So Rocks is just something else, an alternative to Docker. They try to make things more uniform and safe, because, you know, the Docker world is a bit, you know, everybody does like they want. The main problem is you do have the root user running inside the container and so on. And you've Rockcraft as a CLI that just behaves like you can operate like Charmcraft and so on. So it's more a declarative approach there instead of with a Docker file where you have this imperative approach where you say what to install and so on. And similarly to snaps. So with snaps, what they try to do is to have self-contained applications that are easy to update. You have no dependency issues. You have a simpler deployment. That actually comes originally from IoT, where you have the urge to have things automated, because you're not always on the screen, because an IoT is there in the corner, and so there should be some way of automatically updating things. Great. So, okay, let's jump into a quick demo. I'll try to show you a few things, just a few nice little things. Let me just change my screen settings so it's easier for me to work. Okay, so you can see that, right? Okay. Great. So, okay. I prepared some directory, PyCon ops. Yeah, okay. Great. Let's start from, what do we have? Charmcraft. Okay. So, cd. Actually, let's start from the bottom. We have these snaps, because that's faster. So we have nothing here. I have this snapcraft just to show you that we have all this uniform tooling. It says, did it do something? No. We say, okay, we say snapcraft init. So basically what you would do is you would have your application, and in a repository, and inside the repository you would run snapcraft init. And then if you are a Debian developer, or if you have seen in other repositories this Debian folder, so the snaps folder is similar to that. So in your repository, the init command would create the snap repository. If you go in there and you run a snapcraft, pack, then this would start and try to create something. We'll see what it does. In the meantime, oh, now it's already done. Yeah. So what did it do? Oh, it's still working. Sorry. Yeah, it does some dependency building. So basically what it does, it will create something like I would compare it to a Docker image with some layers, because it actually creates a file system. We'll see that later. So in the meantime, while we wait, we do the same thing with PyCon. Whoops. We do the same thing with rocks. So I do a rockcraft inits, okay? And then let's just try to see what we have here. So we have created a rockcraft YAML file. Maybe you see this better like this. And if I open this like this, you'll see, yes, I trust. This, how does it look like? What does it look like? It's a YAML file, so it's more a declarative approach. This, here in the parts, you would define some dependencies, plugins, and so the base would be Ubuntu. This is like the base image you define in Docker, similar. So actually, what I think it's here, you can, no, Canonical has curated Docker images that it uses as base images for that. And the plugins, you can, I think you would list with list plugins or something. Yeah, it's like, I think it's like that, list plugins. And yeah, not like that. So you get the idea. Something similar. Okay, but most importantly, we do a pack here. So because we do the same thing as with snaps. And this will create something else, not a file system, but it will create, when it's done, it takes a while. Yeah, this will create basically a zip file. The same thing will happen, and by the way, also for the charm. So yeah, it takes longer than I hoped, because at home internet connection, but yeah, I don't know. I've got fast web at home. It's a bit slow. I don't know why. It calls fast. Yeah. So anyway, let's try to do another. Open another here one as like Scratch, PyCon. So where do you want to go? we create a machine charm, okay? We make a, what is it, charm craft in it. So what it did, it created an entire file directory structure, and most importantly, it you get this. Oh, that's the wrong. Sorry, that would be for later. Interesting, why that comes here. Oh, that's true. That's totally fine. Yeah, so you get kind of requirements. That's the ops framework that I mentioned earlier. You've got things, you know, test configuration prepared here. You've got tests prepared. You've got the charm prepared for the integration tests, and you have the actual charm here. So it's a class that you know, inherits from charm base, and it has some a few functions. So it is imperative code with a few yeah, declarative you know, points in it. So like you have the configuration here that you can. The idea of this is this an end user should be able to change this easily with a config command. You would just say if the startup is enabled or not, or something similar, or change the environment variables with a command. So and also if you're here, obviously with Charmcraft you could do the pack again. This should go faster, I hope. Let's see where we are. Look, okay, great. With the snaps, we're done. So we have this snap here. If you look at what the snap is, actually, we see that it's, yeah, it's a squash.fs file system. If we mount the squash.fs file system, squash.fs mount, oh, actually, it's like sudo. What did I do? What's, oh. Let me just check this again. Oh. Now I've got my nodes here. Minus t squared. It should actually work. Sudo mount. Oh. Oh, this quite. Yeah, you're right. So my notes were wrong. Like this? Yes. Yeah, great. Okay. So now here, thank you. So you've got basically this structure here. So there's a snap YAML file and directory, a GUI. There's nothing in there, obviously, because we have no application that we actually prepare, but the director structure is there. Great. Okay. So you get the idea. And then, yeah, the rocks are still busy, but that builds, in the end, a zip file, like the charm here. So it builds like, let me just have a, what is the file? Did it run a pack? Charmcraft pack, launching environment. Okay, I'm done with that. Yep. So basically, you get the idea. The last thing that I would show you. Can I still, or sorry? Can I still go? Go ahead. Sure. Good. Oh, less than 5 minutes means I still have 5 minutes. Yeah. So basically, to show you more about the code here. So you know what? What I did wrong here is the Charmcraft init was actually wrong, because that created a Yeah, getting more. Actually, with the charm craft, as we still have machine charms and Kubernetes charms, we have to specify what we want, and we have this thing that is called profile. And if we want the machine charm, we have to say profile, and it's a machine, and then we get a different setup. And so that actually confused me, that's right. And if I do a charm craft pack, that should now go fast actually, then we get a, yes, come on. We get a charm file, there it is. And what is this charm file? You know, it's file, it's machine charm. It is a zip archive, so if I do machine charm, and you can see this contains the manifest files, you know, it just contains the source code. What it does, it packs a complete virtual environment. Why? So it makes it all self-contained. So this operator contains a virtual environment. So basically what it does, and this charm file is then being uploaded to Charm Hub, and Juju would download it from Charm Hub, and it would just run it using that virtual environment. And by default, it runs, it creates this virtual environment, you know, based on whatever Ubuntu version you run. And so the default Python here on 2204, for example. And in the source folder, you have this charm code, you know, for machine charm. This is very simple. On these onstarts, these are handlers that you actually, you know, initialize, and you say onstart here. So it's all actually, you know, self-explanatory. You can go and yeah, debug it, go after it, and try to understand it. And then, most interestingly, we have these hooks, and what these hooks do, for example, the start, is they just start the Python file. So, and what that hints at is that you don't have to use Python if you don't want to. Funny to say on a PyCon, but originally the idea was you could use any technology, but Canonical obviously encourages developers to use Python, so there is uniform implementation for those curated charms. Yeah, so that's what is inside of charms. How would we do the Juju? So if we run Juju, I can show quickly how this is done. I have a more elaborated setup that I've prepared for this. It looks like this. So this is an actual Django application. You can see there are more. I have collapsed all those different functions because, for example, this Django application, it has an integration with a database we defined, you know, with Postgres in this case. So you code this there, and then you can, with the Juju command, you say, don't know really what the Juju, I think it's Juju integrate or so. Yeah, if this errors out. Yeah, but that's not, so this Juju integrate, and with that database relation, it would just connect to Postgres, and Postgres provides an endpoint that automatically, you know, makes them talk. And the cool thing is you can say, Postgres, give me your password. So you don't have to maintain any secrets. You don't have to generate any secrets on the pipeline. It's all self-contained. So a charm knows what it does. And it's the Postgres charm that deals with the secret. I don't have to, you know, deal with creating a user, creating a schema, anything. I just connect the two, and then I start Django, you know, Python manage, PyMigrate, and all that stuff. Yeah. So yeah, I don't have time to show this anymore. how Juju starts up, but maybe I can just try to start micro Kubernetes here on my machine and try to start Juju up while we have questions. Is it fine? Do we still have questions?
I mean, you can choose. You have 4 minutes for questions, but you can use that.
Yeah, no, just let's go ahead, yeah.
Okay.
Thank you. Thank you.
The first one is kind of complicated for me, so if you want to read it for everybody.
Okay. Deutsch, was German? No, this one.
Yeah.
Ist Deutsch besser mit Articles? Oh, mit Artikeln. Der, die, das, Nominativ, Akkusativ. You know, ask my wife. She's Italian. She knows German better than I do. She has studied that stuff. Sorry.
And the second question, a little bit more serious, is what about Windows?
Windows are those things that you get when you make Windows smaller and bigger. Windows are those things. What are you talking about? No, seriously, Microsoft Windows?
Yeah, I think
so. What is the question? So, I don't know if you, so Juju is a Go application. So if you can have a Go binary, I think there is an exe file in the Juju repository in the releases. So if you can run that on Windows, you can probably also run Juju on a Windows machine, and then you can. Yeah, I think you can run I mean, you have also container images that run on Windows now,
also the
right?
subsystem.
So .NET and something.
WSL also.
No, but that's a different story. Yeah, yeah. But you can even run native Windows on.
Linux application on a Windows machine that is like a small virtual machine layer. It's not native.
Let me just. Thank you. Okay. I don't know about that, yeah, but maybe you're right. I mean, you're certainly right. I don't know. Next question.
That's it. I think if
Thanks a lot.